topics that we're going to go through is really the retail trends today and how data is really impacting those trends. We're going to talk a little bit about advanced analytics, and we're also going to be looking at a few customer stories of how customers really used data in effective ways to address business challenges. I'm going to be finishing off with a demo to really showcase one of the scenarios with one of those customer stories. And at the end, we're going to have a Q&A. So some of the trends, and these trends are really based on a survey that we ran, which really discovered that 64% of executives believe that analytics provided them key competitive advantage. And part of that survey also indicated some of the trends that were happening out there that impacted retail. One of the things really is cloud computing. Cloud computing has had a huge impact on retail, mainly because, one, if you look at that second trend, there's a lot of data today compared to many years ago. There's a data explosion. And retailers can make use of all that data today far more than they did in the past in a more cost-effective manner, mainly because of cloud computing. And the data itself, the advantage of data today for retailers is that they can get a lot of insights about their customers as well as the operations than they did in the past. Today, because of a lot of the social data, the open data initiatives, Internet of Things, retailers have access to all of this data and can get a 360-degree view of the customer. And retailers that are actually using this information effectively can become far more competitive, better understand customers, and be able to know the behavioral patterns of customers in store, online, and across different channels by effectively using that data. The other trend that is also impacting retail is really the fact that pretty much everyone, all customers today are connected. And if you look at some of those statistics in there, how many people are on Pinterest and LinkedIn, Twitter and Facebook, these are huge numbers. The number of smartphones out there is exploding as well. And all of this connectivity is changing the landscape for retail. Commerce is really happening in all of these channels, and it's not really restricted to the brick-and-mortar store or online. And that is creating more opportunities for retailers to engage with customers across all of these channels. The other aspect of it as well is the connected technology is enabling retailers to gain a lot of information about customers' behavioral patterns and what they're doing across different channels. And this information is giving them a lot of insights about customer preferences, what kind of products and services do customers like, things like that. It's really the access to all that information and data that it's giving retailers. The other aspect as well, from a trends perspective, is the shift from omni-channel to unified commerce. Omni-channel really was that retailers were either brick and mortar, online, or both, and omni-channel is really crossing those two channels. But today, retailers are finding that they're not necessarily restricted to online and brick and mortar. It's really multiple channels. And customers could purchase on any of these channels, could research on any of these channels, could get recommendations on any channel, so on. And retailers are finding a need to be present across all of these channels and have commerce capabilities across them as well. What this is really doing from a data perspective is retailers are finding that, one, there is a lot of data available across these channels on customer behavior patterns. They can use this information and better understand the customer journey of how exactly a customer moves from one channel to another. What do they do? At what point do they actually buy? And use a lot of predictive and advanced analytics to push customers from one level to the next, or move them towards a sale. And this is really a lot of the trends that's happening out there that is driving advanced analytics. I would say cloud computing, one, is enabling retailers to handle large amounts of data. The data is available mainly because of social media, open data, and so on, as well as the connected technology, and there's all of this behavioral information available across channels. And unified commerce is that retailers now can act across all of these channels using the information that they're gathering from all of the different sources. So one, there is a lot of data, and at the same time, there's a lot of challenges as well with the data that retailers are facing today. One is the data is easily available, but the other aspect is a lot of retailers, as part of the survey, what they told us was that they're still struggling with the data silos. And if you look at the slide here, it shows that 16% are really challenged with breaking down existing silos. This is typically a challenge when dealing with campaigns, trying to understand the impact and ROI of campaigns, where the impact of the campaign could happen across different channels. And a lot of retailers are not effectively really combining data from across those channels. The other aspect that retailers are looking at as well is better understanding customers. And to understand customers, they're looking at data from social media, from demographic data sources like the census. They're looking at data of in-store behavior, online behavior, and also behavioral data and preference data that they're getting from social media sources. So again, here there is a lot of data sources that can provide a 360-degree view of the customer, and retailers are struggling with trying to figure out how do we combine all of this information in order to create a personalized experience for the customer. And the other aspect that a lot of retailers are looking at from data is really how do we improve the effectiveness of the operations? How do we improve inventory and assortment and things like that with better forecasting? How do we better understand the customer? What are the trends out there? What's the demand for a certain product, and so on? And that's the other aspect where a lot of retailers are saying, can we use not just the past purchase data, but also the external trend information, the correlations between demographics and sales, the correlations between weather and sales, to better predict demand for certain products. So all of these challenges are typically addressed with advanced analytics. So advanced analytics enables retailers to combine data from multiple sources. So this could be data from social media sources. It could be data from census data, demographic data. It could be economic indicators combined with the retailer's proprietary data. So when all of this data is combined, it is possible for retailers, one, to better understand the customer and deliver a more customer-centric experience. In addition to that, they also get a better understanding of the customer's journey through the different channels. They're able to understand what did the customer look for online, what has the customer already bought from different sources online and in store, and what's their browsing behavior across the different channels. Combining the data from these different channels, they get a 360-degree view of the customer, are able to better understand the customer, personalize the experience, and make it more relevant for the customer as well. In addition to that, all of the data available and the ability to combine that data and the ability to use advanced analytics and machine learning on that data, retailers can answer a lot of questions around things like what should their inventory be in a certain store? What products will be popular next season in a particular store based on the information that they get from correlating demographics and sales, weather and sales. the trending topics in social media and sales and so on. So combining all of this information, it is possible for retailers to become far more effective, more competitive, deliver better customer experiences, and also improve the operations and become more competitive. So I'm going to go through a few stories of what customers have been doing with combining data and actually using data to improve customer experience, to improve operations, and so on. So the first story is from McDonald's, and this was McDonald's in the Netherlands. So they worked with one of our partners called VMob, and one of the big challenges they had was they were trying to figure out how can we better understand the customers in the store. At this point, McDonald's really was dealing with a nameless, faceless population that was going through their stores. They wanted to better understand the demographics of their customers, the behavioral patterns, and so on. They had an existing mobile app, but the mobile app was seldom used. So to address that challenge, what VMob really did was work with additional technologies, like, for example, in this case, they used beacons, geofence the McDonald's stores. So when a customer was in close proximity of the store, it automatically brought up personalized menus. The personalized menus were based on past purchase behavior and actually used advanced analytics and machine learning to accurately predict what the customer would be looking for based on past purchases, based on current time, based on location, and so on. And this would be a short menu that the customer could pick from. The order would go to the kitchen and would be ready for the customer to pick up as soon as he walks in. What this did was, the value proposition in this case was it enabled customers to speed up the process with which they go through a McDonald's. It was a huge value to the customer, and as a result, we saw the downloads of the app actually increase. One of the statistics that we got from this was that 10% of the Dutch population actually downloaded the app. This was a huge jump from what it was. Also, the other aspect was there was an increase in the use of coupons in the store. So 2.1% of all McDonald's customers use at least one of the mobile coupons compared to the traditional coupons. McDonald's also saw a 47% increase in the tray value for the customers using the mobile coupons. So McDonald's did see a huge advantage, or rather a benefit, in using the mobile application. There was an improvement in business. There was better engagement with the customers. But most importantly, from a data perspective, what you see here is a screenshot of the dashboard that they were looking at, which gave them real-time information about what was happening in the stores. This one is actually of the operations in Sweden, where on the right, what you can see is you can actually see all of the stores in Sweden, and you can see how many people are in each of the stores. You can also see things like how many of the mobile coupons are being used versus the non-mobile coupons. So there's also, you can actually see here the benefit of the mobile coupons, the number of visits, the average coupon value and discount. So there's a lot of real-time data that McDonald's had access to because of the mobile application. The other aspect of it was because the customers were using a profile or a social media profile, they also got very detailed demographic information about the customers within the store. So they knew exactly if it was a 20-year-old in the store, what was the age demographic of people in specific stores, what was the income demographic of people in stores, male versus female, what kind of coupons were they redeeming, how successful are certain promotions they were running. So there was a lot of real-time information about their promotions that was available to McDonald's. And this was, again, a huge leap from what they were doing before they actually had success with their mobile applications. So another story is from Pier 1. So Pier 1, what they were trying to do was figure out in their stores, they had traffic, but at the same time, they were struggling with conversion. One of the suspicions here was that the assortment in the stores was not relevant to the customers. And they were trying to figure out how can they make the assortment far more relevant to customers. In order to address this challenge, we actually used advanced analytics and combined data from multiple sources. One of the sources of data that we had access to was the weblog data from Pier1.com. So Pier1.com had extensive weblog data that told Pier 1 about what customers were doing online on their site, what products were they looking for, what were they adding to their basket, what were they removing from their basket, and also their locations. So they could tell people from Seattle what were they looking for, people from Atlanta what were they looking for, and so on. What was popular at different times of the year in different parts of the country. So this was very detailed information they were getting from their online site and what people were doing online. But in the store, they had absolutely no information of what people were looking for, what was popular, was available, but just based on the sales, not based on the behavior of people within the store. So we actually looked at the data from the weblogs as well as the sales data, the locations of the store, combined all that information and refined the assortment in the store based on what people were looking online. So what we have here is really a visualization of all those data layers. This is, again, obfuscated data. So what you see here is several layers of data. The first layer of data is really all of the customers, where the customer is coming from when they're browsing Pier1.com. You can actually see where they're coming from. The thicker clusters are the larger populations of customers that Pier 1 has got. We also took census data and put it on the map as a heat map. So what you see here is income levels. So we could effectively correlate income levels to the customers of Pier 1 to determine what was the correlation between income and customer. In addition to that, we also build an advanced analytics model to determine the lifetime value of every customer. So what you see here in purple on the map is really the lifetime value depicted and where exactly they're from, and then the correlations to the income level. And finally, what we did here was we looked at the search data from Pier1.com, and we categorized that to depict here what are people looking for in Seattle. For example, here you can see in Seattle, they're looking for candles, kitchen and dining essentials, and so on. And we also looked at the store locations and combined that into a model to determine what kind of assortment should we have in the stores in Seattle based on what people were looking for. So this, again, it helped address the challenge that Pier 1 had on determining what kind of assortment is going to be relevant and personal for customers in different parts of the country. It also enabled them to determine which parts of the country they should have a store based on what people were looking for and where they were from, and where the larger concentration of customers were based and where the smaller concentration of customers were based. The next story is from Arca Continental. They're a Coca-Cola bottler based out of Mexico. And one of the challenges they were looking at is using data to make data-driven decisions. So they had a lot of data available to them. One was the internal data, which is their sales data, the marketing data, how much investment they make in things like TV advertising, radio advertising, social media marketing, and so on. And they also had access to external data, things like the weather, things like competitive pricing, and so on. So What we did with this is we worked with a partner here in Seattle called Neil Analytics, and they went in and built an advanced analytics model for Coca-Cola to address the problem. So I'll actually walk through the entire business case and how Coca-Cola addressed this using a demo. So we'll begin with a dashboard that kind of looks past sales. This is like a rear view mirror. This is descriptive analytics or diagnostic analytics, where I look at what's happening in the different categories, in the different areas, and so on. So what I see on the top right is really the overall sales, the actual sales versus the forecast. And what I can see is the actual sales is slightly below the forecast. And on the left, I've got a map that shows the deltas for the different cities. And I can see that Seattle is in the red. So I'm guessing that that's probably what's causing the actual sales to be below forecast. So let me actually click on that on Seattle to drill down. And when I drill down, what I notice on the right is that the actual sales is indeed way below forecast. If I look at the different categories below, the juice segment, water segment, and soft drinks, I notice that soft drinks is the cause for the problem. So I'm able to actually drill down and find out what's really causing the sales to be below the forecast. Now, this is going to tell us what happened. It is not really going to tell us what to do about it. So what we really want to be able to do is use advanced analytics, take all that data, and figure out, can advanced analytics tell us what we need to do about this problem? How do we fix the sales? So in order to do that, what we did is we used predictive modeling and used the existing data. So to begin with, we used the proprietary data that Arca Continental already had. This was really the internal transaction and marketing data. So this included things like the stock up, the price elasticity, the spend on radio advertising, the spend on TV advertising, the SKU presence, whether it was on stock or not, things like that. So when we took this and we created a predictive model with it, what it really did was break it down and determine what the drivers were that impacted the final sales. So the breakdown actually enabled us to explain about 25.6% of the total sales. And here we can see there is a certain percentage of that was influenced by price elasticity. A certain percentage was influenced by radio advertisements. A certain percentage was influenced by TV advertisements, and so on. So we know how much of the TV advertisements really impacted the sales. But this percentage is not really enough for us to control the sales. So what we did is we took some additional data like weather and economic data, the competitive price gaps and things like that. And we added it to the advanced analytics model. And what this enabled us to do was it enabled us to look at far more influencers and drivers that impacted the sales. Because of the additional data, we were able to get additional drivers. In this case, we were able to go up to 49.7% of the total sales. And here we are looking at things like how much of this was impacted by radio advertisement, TV advertisements, the competitive price gap, by the weather, by the household size, by the population, and so on. So there was much more variables that we were working with. But because of the availability of a lot more data and things like IoT and things like that, we were able to get additional data sources. So we went in with a third data source, which was the Internet of Things data, the sensor data from within the stores that told us how much in-store traffic we have, and also how much product we have on the shelves and things like that. So when we added that data, we were able to explain about 89% of the sales, and the number of influencers grew as well. So here we have a lot more influencers. We have the competitive price gap, the weather, the population, the household size, the spend on radio advertising, the mobile traffic, the in-store traffic, the web traffic, and so on. So all of these were influencing the sales. So the next step was really to figure out how can we now take all of this data and figure out how do we now control the total sales. So this waterfall analysis that we did next really shows us on the right what the current month sales were, and on the left it was 4 weeks ago in the previous month. And when we did the analysis, the green bars are really the influencers that have a positive impact on the sales, and the red bars, the influencers that had a negative impact on the sales. So in this case, for example, I've got social media engagement that had a positive impact. Mobile traffic had a positive impact. Own brand advertising had a positive impact. The competitive price gap had a negative impact. So it really shows which of these influencers had a positive or a negative impact on the sales. What we can do is we can use predictive analytics and further analyze and say, what if I were to decrease the competitive price gap by 5% or 10% or 15%, I will see the impact on the overall sales. So this is, again, a great way for businesses to use data and say, once I determine what the influences are, and then I determine which ones I can control and which ones I can't control, I can go after the controllable variables and use predictive analytics on those and say, what if I increase or decrease any of those controllable variables by a certain percentage? How much lift am I getting on the sales? And you can actually look at various combinations. And this is, again, what Coca-Cola was doing, what a lot of companies that we're working with are doing. They're looking at how do we now control all of these variables to improve our sales. Which of these are controllable? And can we predict if we increase spend on social media, how it will impact the sales, and so on. So here again, we're looking at social media and what the impact will be. So when I click on social media, it's using predictive analytics to predict the impact on increasing the spend on social media advertising or radio advertising or TV advertising and so on. In this case, weather is a non-controllable influencer, so that's something we can't control, but the rest we certainly can. So finally, what we're looking at here is the overall impact. We can see the black bars are really the actual sales, and we can see that if we did nothing, the sales would be far below the forecast. But if we actually look at the breakdown that the model gave us and said, own brand advertising has a certain percentage impact on the total sales. Social media traffic has got a certain impact on overall sales. And we use predictive analytics with that and increase it. In this case, we increase it by 20%. We can actually see the impact on overall sales. So in this case, we're actually going way above the forecast by increasing own brand advertising by 20%. So all of this was really done, one, because of the availability of data, and two, because of advanced analytics. So it is the combination of the data and advanced analytics we were able to make these data-driven decisions. So in all of those examples, what we saw was with McDonald's, it was how do we engage with the customers better, and also how do we better understand who our customers are, what their behavioral patterns are, and then use that information to deliver more personalized and relevant engagement with them. With Pier 1, it was also, again, how can we find information across different channels? So we looked at getting information from online and really using that information to make the in-store assortment more relevant for customers. And finally, in the Arca Continental example, what we looked at is how can we improve sales and efficiency and competitiveness by determining where exactly should we increase investments? Where should we decrease investments in a more data-driven way? So data really enabled us to determine what those influences were, which ones were controllable, and then enabled us to control it using predictive analytics. So with all of this, what retailers are doing is they're saying all of that data is available, and winners are the ones that can actually take advantage of that data, become far more effective, connect better, deliver more personalized experiences for customers, and thereby drive retention, as well as ensure the optimal inventory in the stores that are personalized for the demographics around the store. And finally, we go to Q&A.
Thank you so much for your presentation, Sheesh. Now it's time to get started on the Q&A portion of the webinar. If you haven't already done so, please feel free to type your questions into the Q&A window on your console, and Sheesh and his team will reach out to as many as they can. So back over to you, Sheesh.
Thanks, Philippa. So I'm going to read some of the questions that we have here that have been coming in. I can see one of the questions here: is there an established line between business data versus personal data collection where it becomes creepy for the customer? And there was, again, I'm kind of reading all the questions in there. There was another question that was posted as well around privacy, and I think the response to this is on similar lines, where you have the privacy being a huge concern for retailers, where things like opting in is an essential part of how retailers go about collecting the data, ensuring that there is opt-in capabilities where customers can explicitly opt out or opt in into data collection. And the other aspect of it is transparency, where the more transparent retailers are about how that data is being used, that it is being used for convenience, it is being used for personalization and relevance and all those kind of things. Consumers or shoppers are generally more, they're willing to share that data, but when they're not sure what the data is being used for, that's when the concern comes up. And that's based in some of the surveys we've done where we asked shoppers about privacy. So things like the personal data versus business data. One of the guidelines, of course, is that personal data, if there is personally identifiable information, it's certainly not okay to collect it. Generally, what is done by most retailers is aggregations of that data rather than the identifiable information. Then looking at other questions in this list. So there was a question also, did you use R or Python to do it completely with, or do it completely with Azure ML Studio? So this, I reckon, is aimed at some of the Azure ML examples in there. One of the things about Azure ML is a lot of the data science experiments can be built entirely in Azure ML. Generally, a lot of companies that have investments in R and Python have done a lot of work around R and Python will do a combination, where Azure ML easily enables companies to embed R and Python code into Azure ML. In such cases, a lot of companies have been doing a combination using R in a lot of cases where they're building custom modules and things like that. In this particular case, there was one module, I believe, which was built in R. So it was a combination of Azure ML as well as R. And we have, let me see what other questions we have in here. So there is a comment, opt-in and opt-out is a big risk of introducing bias in data, and that is true. There might be, because we're only using opt-in data and not using opt-out data, there is a possibility of having bias when you use all of that data. So part of what Azure ML Studio has a capability of doing is really normalizing data, where if you have data sets that is skewed to a certain category or group, because, for example, if this was a survey data that was collected from groups of people and the responses came from one group, and we noticed that the data set is so skewed to that group, what Azure ML tools have the capability of is finding such skews and really normalizing that data so that it is more balanced. So there is a lot of data cleansing tools, data normalizing tools available in Azure ML that can help address those challenges as well. I'm looking at additional questions in here. Some of the questions are technical, things like what are the file formats and things like that. So we will respond to that directly. You can actually send me an email. I will share my email address, and I can help connect with the engineering teams to address some of the questions that are more of a technical nature. Yep. So there's a couple of questions I see in here that is about product capabilities. There's another question about how do you make a distinction between correlation and causality. If people buy more, they will tweet more. It doesn't mean that tweeting more will increase sales. And I think the correlation versus causality is a massive discussion in advanced analytics and machine learning. Again, a lot of the data normalization tools, the patterns over time is another aspect that a lot of data scientists will look at when trying to sift between whether causality is correlation or not. So there is massive discussions around that. And the tools, Azure ML actually enables you to normalize that data as well. One of the questions we have is, do you have examples of how retailers use public data to determine the best locations for stores? And the open data, essentially the open data initiatives have enabled retailers to have an access to a lot of public data. And retailers can now access things like the census data, information about bus stops and train stations and parking lots and things like that that are in a particular location. They can determine how many parking lots are in a certain area. And when they combine this information with the existing sales data, demographics data, the income levels, the age, the location of the parking, the size of the parking, the bus stops, and other variables, what happens is they can actually create scores for each of the locations and make decisions that are data-driven to determine which of these locations can give them a higher ROI. And that is one of those things that a lot of retailers, if you actually look at solutions from companies like Esri specializes in location analytics. They actually look at data sources, all of these public data sources, and enable scoring those locations and enable retailers to really use that combination of data to determine which locations can be more profitable with that combination of proprietary data as well as public data. Right, let me see if there's any more questions in here. So one of the questions here is, I'm exploring the idea of data analytics, but do not have a lot of data currently. Your slides clearly stated better data, better models, but how to determine how much data is enough to start building these models. So to answer that question, one is a lot of companies do have what Gartner refers to as dark data. There is silos of data in every organization that is potentially not used. So one of the recommendations is there might be a single data set that you're looking at that may not be enough, but when you combine the data across different groups, you tend to get insights across different areas about a customer or operation and things like that. And that's the one aspect of it. The second is a lot of companies that I work with are looking at not just the data they have, but they're saying, if I were to look at sales, for example, what's the impact that weather has got on sales? I want to find out when the temperature goes up, when there's a storm out there, when there's snow out there, are there specific categories that spike and so on? And in order to answer that question, I would look at weather data sources, pull that in, combine that with the data I have, and be able to determine what kind of correlation or impact does weather have on sales. Then I would look at demographic data and so on. The question here is, how do you determine how much is the data enough? One of the things that Azure ML or machine learning tools do is look at the historic data, and typically you would take about, say, 70 to 80% of the historic data, build or train the model with it, and then use the remaining data to score the model with. Typically, that scoring process would tell you whether the accuracy of that score is good enough or not. If I get a score of, say, 60%, that's as good as a coin flip, and where 50% would be a coin flip, and I'm getting a 60% in predictive analytics, that's not good enough. So if the score is not good enough, it's an indicator that you do not have enough data you need to have. And this doesn't necessarily mean the volume of data. It could also mean the diversity of data. Improving the diversity of data could give you a better score. For example, I may not have enough transaction data to get the right accuracy, but I could use weather data, I could use economic indicators, I could use external data sources to try and improve that score. So that's one of the ways that I could look at for getting a higher accuracy on that prediction. Typically, when I work with companies, they also look at this and say, where can I get all of this data from a single source? And typically the best way to do this, instead of trying to figure out how do I get Twitter data, Facebook data, demographic data from different sources, is to work with data brokers like Axiom and Experian and all those companies that aggregate these data and make them available to companies very easily. This would be the quickest way to acquire the weather data and demographic data and social data and so on, and be able to build the models with it. And I'm looking at a few more questions to see if we've got any big ones to answer. So one of the questions here, this is a rather indirect question, but I've been met with, what is the business case for this project? How many times when trying to do something more than rear view analysis, are there any tips for making a business case for non-technicals? I would say the way to make a business case really is, I'm looking at example, like for example, the Arca Continental one, where they were trying to improve the forecast. In this case, it had a specific financial implication. So we looked at what was the impact of out of stocks, what was the impact of overstocks. We determined how much it was costing them in terms of losses, and how much accuracy, what was the percentage accuracy they were getting with the current predictive analytics. And as a result, if we would improve it by 10%, what would be the savings? And that was really the approach that we looked at to say, is this something that is feasible? Is this something they should be looking at? And in order to prove the case, the best way to do this would be to take a historical data, and using that historical data, be able to build a quick proof of concept. And with tools like Azure ML, it is fairly easy to build a proof of concept with that historic data, take about 80% of data, train the model, score it against the remaining 20%, take external data sources as well as part of the training, and then do a side-by-side comparison to see, are you getting improved accuracy in that model? If you are getting improved accuracy, how much percent is that, and how does that translate to savings for the customer? It looks like we are actually approaching the top of the hour, so until that we can respond to the questions offline. I will look through the questions and post those on my blog. At this point, I'm going to turn it back to Philippa.
Thank you so much. Yes, we did indeed have a lot of questions come through, and we were not able to answer all of the questions. So please feel free to type the word yes into the Q&A window if you haven't already done so. That gives us permission to reach out to you afterwards. Thank you so much. Okay, so the slide that we have up right now is the next steps available to you, and these two different resources are available on your resource window on your console. So feel free to click onto those. The first is download a copy of our Advanced Analytics ebook, and the second is visit the Cortana Analytics Suite page. Now we're almost done here. We'd love to ask you another couple poll questions just to finish up. And the first poll question that we would like to ask you is whether you found this webinar useful. And if you wouldn't mind just clicking one of those, not useful, somewhat useful, or very useful, that would be useful for us. And then if you wouldn't mind hitting submit, that'd be great. Thank you. And then the final question here, what would you like to learn more about? And this is your chance to actually type in a response here. So we'll give you a minute to answer this one. And this helps us to determine where to address your needs or how to address your needs for the future. I'll give you some more time to type your answer there. And then once you're done, please hit the submit button. Okay, thank you very much. Once again, thank you for your time today. As a reminder, you will receive a link to the recorded session and to the slides. This concludes our session for today. Thank you for joining us.